Okay, so we're now on part 2 of our data representation topic, and we're going to be looking at three different things. So it's data types and data structures, and that can be broken down into how we can describe, interpret, and manipulate data structures, represent the operation of linked lists and trees, and select and justify appropriate data types and structures for given situations. Okay, so there's 4 basic data types, and these are an integer, which are whole numbers, real, which are numbers that can be fractional or standard form numbers, string, or more correctly, character, and then Boolean, true or false. A data structure is a collection or group of related data items. A data structure collects together these basic data types and allows data to be organized in a convenient, logical manner related to the program being developed. Data structures are held in memory, and therefore the data in them is lost when the computer is turned off. This is usually not a problem, as it's easy to write procedures to copy a data structure into a file and load it back in again when a program starts. As data structures are held in memory, it means that data can be accessed, searched, and sorted much more quickly than data held in a file. The first 2 data structures we examine are arrays and records. These have already been studied at AS, but you may get questions on these on the A2 paper, in particular arrays. So some of this is more of a recap. Okay, so you've got a one-dimensional array, and this can be used to represent a list of data. So for example, in Visual Basic, you've got dim books 1 to 5 as string. This creates an array with 5 elements, numbered 1 to 5, each element being a string. So we've got books 3 equals Oliver Twist, books 5, The Hobbit, then print books 3 will print Oliver Twist. So what we need to think about is what would happen if we instead said print book 5. Okay, which book would it print in? A 2D or 3D array can be used to represent tables of data, I should say, not date. For example, the record sales figures for 5 salespeople for each month of the year. So dim sales 1 to 5, 1 to 12 as integer. Salesperson 4 makes £8,700 worth of sales in August. So your sales 4, 8 equals 8,700. So you're trying to find the amount of sales for salesperson 4. Salesperson 3 makes £500 worth of sales in December, so it'd be sales 3, 12 equals 500. If the company wanted to record sales over a 10-year period, a 3D array could be used. So dim sales 1 to 5 would give you the figures for the salespeople. 1 to 10 will give you the year, and 1 to 12 will give you the month. Salesperson 5 makes £650 worth of sales in February of year 7. So you would use 572 to give you the figure 650 from that array. So there's some advantages and disadvantages of arrays. So the advantages are elements in an array can be accessed directly without any searching required. For example, print sales 358 would immediately print the contents of that cell without needing to search through any other elements. Disadvantages are arrays are static data structures. The size is set and can't be changed dynamically as the program runs. So an array that might eventually hold 1,000 names needs to be set to have 1,000 elements, even if 800 of them are currently blank, and that's then a waste of potential space. If a new item of data needs to be inserted into an element or an array, all the elements after it need to be shifted up to make space for it. Similarly, if any element needs to be removed, the elements after it are shifted down to fill the gap. All the elements in an array need to be of the same data type. For example, you can't have a 2D array where some rows are integers, some rows are strings. Though an array of record data structures could be used for this, and we'll see that on the next slide. The record data structure allows items of data relating to something to be grouped together into a single record type, for example, pseudocode. So you've got TV program equals record. Title is string, channel is integer, high def as boolean. Variables can be declared as being of this type. So you've got dim as TV prog, and then you've got, or dim x as TV prog, so x.title equals EastEnders, x.channel equals 1, x.high-def equals true. And this will be a very, very good tool to use in your coursework as well. It is also possible to create arrays of records, which gets over the issues of not being able to have mixed data types in an array. So dim programs, or dim progs 1 to 20 as TV prog. So progs 1.title equals Coronation Street, progs 2, panorama, and so on. Okay, so that's record structures and arrays. So we've got stacks. Okay, the LIFO or LIFO data structure. So a stack is a last in, first out data structure. Although stacks can at first seem a bit odd and pointless, they are used in various places in computing, and one example is the runtime stack mechanism, which an operating system uses when running a program to keep track of where it's up to when making procedure calls. Another example would be the back button in a web browser. The last page visited is the first page to be loaded when back is clicked. Another example could be the undo feature in an application. So the last action carried out is the first action to be reversed when undo is clicked. So you add data to the stack, and then you remove data from the stack. A stack is implemented using an array and a variable known as a stack pointer, which always points at the last element added to the stack. So there's 2 items on the stack, and bbc.co.uk is at the top of the stack. If we were to add Holy Cross, which is another college, if we were looking at them, we would add 1 to the stack pointer and place the value in the position indicated by the stack pointer. So we've incremented by 1. So the next item in the stack is holycross.ac.uk. So if we wanted to display the items indicated by the stack pointer, we would then subtract 1 from the stack pointer, and holycross.ac.uk would be displayed on the screen. Okay, so you are very unlikely to be asked to write about these in the exam, but they are very easy to understand, and it's very good practice for understanding pseudocode. So if we were to have a procedure, add to stack, get item, if stack pointer equals limit, error message stack full. Else, stack pointer equals stack pointer plus 1, and then stack equals stack pointer equals item. Okay, so what's actually happening here is we're saying if the stack pointers, or if the stack's full, so there's no space left in the stack, we're going to display this error message stack full. Otherwise, we add 1 to the item, or add 1 to the stack pointer and insert the item into the stack. Similarly, if the stack pointer equals 0, error message stack empty, so you couldn't press back on that web browser anymore because there'd be no web pages to go back to. And then you would decrease 1 from the stack if it was able to be displayed. So with queues, it's a FIFO data structure, so it's the first in, first out. And it's like a queue in real life if we were queuing up in a shop. The person at the front of the queue would be the first to be served. In computing, they are used in various situations, such as queues of jobs waiting to be printed, or processes waiting to be processed in a round-robin scheduling process. Queues are often implemented using an array and 2 pointers to indicate the start and end of the queue. So it starts at position 3 and ends at position 6, and we've got A, B, C, D in the queue. Okay, so adding data involves incrementing 1 to the end of the pointer. So the queue now ends at position 7. Removing data involves displaying the data in position in the start position and then incrementing the start pointer by 1. The queue is circular, so if the endpointer goes beyond 8, it then starts again at 1. Obviously, it needs to deal with a special case where the queue is full and an attempt is made to add an item to the queue, or if the queue is empty and an item is removed. Okay, so again, that's just what's happening if we get up to 8. So we start at 4 and we end at position 1. Okay, you don't need to know this for the exam, but it's quite useful to be aware of. Here's some pseudocode for a queue to add an item into the queue. So we've got procedure add to queue. We input the item. If start equals 1 and end equals queue max, or end equals start minus 1, then display this error message queue full. So here we are saying that the queue is full. Otherwise, if end equals 0, then start equals 1 and end equals 1. So we know exactly where to go to. Else if end equals queue max, then end equals 1. So there we're looking at the end pointer at the last element in an array, and it has to loop back to the beginning. Else end equals n plus 1. So that is our standard case. So what would happen normally, where we would just add 1 to the queue, to the pointer for the queue. Okay, again, what we're saying is if start equals 0, then display queue empty, there's no items to remove. And then we've got our 2 special cases. So there's one item in the queue, so empty it. We've got another special case, so we're saying start pointer at the last element in an array, so it has to loop round back to the beginning. And then we've got our standard case, so increment the start pointer by 1. Okay, linked lists. So a linked list could be used to hold a list of data, but has a few advantages over using a 1D array. A linked list is a dynamic data structure. Its size can be increased and decreased as required. An array is static, therefore is fixed. Items can be added into a linked list without having to move the existing items to make space. Items can be removed from the linked list without having to shift the other items to fill the gap left. And a linked list usually consists of a start pointer, which points at the first item in the list. This item will have a pointer to the next item and so on. There is often another linked list of free locations, although exam questions never seem to refer to this. Items are deleted from the linked list, or items that are deleted from the linked list are added onto the front of this free list. Items that are added to the linked list are obtained from the front of the free list. And a linked list can be used to represent 2 arrays for the data and the pointer to the next item. Okay, I'm going to go through this slide on the next video, so stay tuned and I'll be back with you in a second.